Okay, all right. Hopefully that terrible echo from my first attempt at this is now gone. All right, so hopefully the echo is gone and we can do this. So I'm trying to get all technological here, and I'm gonna have a little board here that I can write on, and that will move my mouse around, and hopefully we can try this. So I'm gonna move over to the screen capturing software here, and we're gonna see if we can do the first problem or if I can explain the first example here. So get ready. Here comes the mischief. Okay, so I press that button and then this happens. Isn't that wild? Isn't that wild? Because it's capturing my screen. Let me go over to where we need to go. Okay, hopefully you can see this. Hopefully you can see this. Hopefully my head isn't in the way. Yeesh. You know what? I can make my head go away, can't I? I bet my head will be in the way if I do that. So let me. I know you all want to see me, but there are other more important things right now. Okay, so now I'm gone, and here we go. Hello, and we have example one here of let's see. This is part two of the preparing a budget unit. So this is prepare a budget. Two electronic utilities. You came in here. This is the unit plan. This is what we're going to talk about. You put your name in here already. You are going to always click submit. There's your learning targets. This will eventually become a video of me introducing this topic. There's some text for you to read. There is some trying to add some trying to add some multimedia here. Right there. That's just a random image I threw in there, so it's not all text and it's not throwing you off too much. You're going to put your learning targets in there. And this is where the instruction for this video is going to go. This is instruction from the last video. This is where this video is going to go right in here. And so we're beginning example one of electronic utilities. And the question is, determine the cost of a 7.5-minute phone call at a payphone. So here's the situation we've got. Even with cell phones, there are still hundreds of thousands of payphones across the United States. I believe that's still true. I don't know the last time I used a payphone was, though. But I believe that's still true. A payphone. Have you ever used one of those? I don't know if many of you have. A payphone at a local airport charges 35 cents for the first 3 minutes or any part thereof, and 19 cents for each extra minute or part thereof. You will get charged for an entire minute regardless of the portion of the minute you used. So if you make a phone call for 7.5 minutes, like this one, how many minutes are you going to get charged for? You're going to get charged for 8 minutes because they're not going to charge you for half a minute. It's going to be the biggest whole number rounded up, right? So 7.5 gets rounded up to 8. A 5 minutes and 1 second phone call will get rounded up to be a 6-minute phone call. So that's just how they charge because they don't want to have to split the difference of that kind of thing. So what would you find the minute of a 7-minute phone call? Well, hopefully my pen will work. Is it working? No? Technology is not. Oh, there we go. It's just a little slow. It's fine. My pen's just a little slow. Okay. So first thing we're going to do is we're going to say the first 3 minutes cost. Remember the first 3 minutes? The first 3 minutes here cost 35 cents. All right, thanks. Nope, I didn't. Okay. The first 3 minutes cost 35 cents. So we're going to have a function here. There's going to be some, eventually I want you to think about these in terms of functions. You don't need to do that at this point. But I want you to think of, okay, there's going to be a 35-cent charge. And in addition to that charge, I'm going to get charged for 19 cents for every minute. Charge 19 cents for every minute. Well, we could represent minute as like M, right? We could call every minute equals M. So I could put an M in here. So what does this say? This says I got a function where the y equals such that I'll get charged 35 cents. I'll get charged 35 cents for at 35 cents plus 19 cents for every minute. If I talk for 10 minutes, this will be $1.90, right? 10 times 19 cents would be $1.90. And then the $1.90 plus 35 would equal how much I get charged for a 10-minute phone call. So in this case, let's look at this. That's how we look at how they figure out a 7.5-minute phone call. The first 3 minutes are going to cost 35 cents. We're going to subtract the number of minutes over 3. So we're going to take 7.5 minus 3. So this is 7.5 minus 3 equals 4.5 or 4.5. So this here, this 4.5, that's going to get charged the 19 cents per second, right? That's going to get charged the 19 cents per second. So let's see. Well, 4.5 minutes, remember they're going to round this up. They're going to round this up. Oh, sorry about that. That's my little clock in the background. 4.5 minutes is going to get rounded up to 5, all right? So because this is over 4, and the initial 3 minutes we don't count, the first 3 minutes is going to be 35 cents. First 3 minutes. That's why we subtracted 3 right here, because the first 3 minutes are going to be under a different category of charge. The remaining minutes are 4.5. That's going to get rounded up to 5. We're going to get charged for 5 minutes. 5 minutes at 19 cents. 5 times 19 cents gives us 95 cents. So we're going to get charged 95 cents plus the 35 cents, right? So let me turn this off, which allows me to scroll down, right? And then I'll turn it back on. Nope, I'll turn it back on, and then I'll delete all the stuff I did. Boop. Okay, gone. Okay, so the extra 5 minutes, this extra 5 minutes over the first 3 costs us 95. So our total charge is going to be the 35 cents plus the 95 cents. The 35 cents is for the first 3 minutes. The 95 cents is for the 4.5 minutes rounded up to 5 after that. So our total charge for this call is $1.30. Not too hard, right? There's some subtraction involved. There's some kind of rounding up to the largest integer from that point, and then some multiplication, and then some addition. That's all that's really happening here. That's not that bad. Let's see. I want to delete that, and we'll go to the next one. Now, this is the part where you really should pause my video, this video here, and you should really try this on your own. You should really give this a shot. Try it on your own, because if you don't do it on these on your own, you're not going to really get the full learning experience of trying to kind of puzzle these out and figure them out. So what I'd like you to do right now, please pause the video, and we'll get back to this, all right? So pause the video now, and I'll show you how to do it. Great. Now you're unpausing me, right? Because you tried this. You tried this. I know you know what's best for you. All right. The cost of a 12.25. What's this? This 12.25. Well, that's 12 and a quarter. Sorry. I can't really do fractions that well on these Google Forms. So originally this problem looked like this. That's 12 and a quarter. I put in a decimal to make it easier. All right, using the same situation above. So it's 35 cents for the first 3 minutes, and then 19 cents for every additional minute or part of. Okay, so let's figure out, let's take away that, remember we subtracted 3 above, remember we subtracted that first 3 minutes. So what is 12.25 minus 3? You're going to break out your calculator here, and you're going to figure this out. Okay, break out a calculator. Maybe pause this if you need to go grab your calculator. Okay, you unpause the video, and okay, that's going to be 9.25. I did that in my head. I hope I'm okay on that. All right, so this is what we got going on. The first 3 minutes is going to get charged 35 cents. So we're going to have before our final answer, we're going to have, oops, I did goof that up, 35 cents for our first 3 minutes. That's for our first 3 that we're taking care of right here. That's our 35 cents that we're eventually going to get charged for that first 3 minutes. And now we got to take care of each additional minute thereof afterwards, right? That's that 9.25. Well, now, remember, they're not going to charge me 9.25 minutes. They're going to round this up to what? Yes, they're going to round this up to 10. So they're going to count these 9.25 minutes, 9.25 minutes as 10 minutes. Now, how much are they going to charge me? They're charging me 19 cents for each extra minute. 19 cents per minute for each extra minute, per minute. Well, we're going to multiply here. Multiply. When you hear per or for each, we're thinking multiplication, okay? So there's my 19 cents times 10. Oh, that'll be $1.90, right? I did that in my head. Hopefully you broke out your calculator. I should have made you do that on your calculator. What was I thinking? Okay. So 10 times 0.19. You did that on your calculator, or you heard it from me. $1.90. So what I got to do is I got to take my 35 cents, and what I got to add. I got to add my 35 cents with the $1.90 to get this answer that you will put here. I'm not going to do this. I'm going to actually make you pick up your calculator and do some of these. So I'm not going to always give you the full answer. I think you can handle this, right? You can handle that. Yeah? All right. I'm undecided how best to do these. sometimes I wonder it would be best if I did a video for each individual example, but that is also a little bit more tough for me. So it takes a little more work for me to upload all these. So I'm just going to keep going. All right, example 2, piecewise split function. All right, so we're going to use the greatest integer function to express payment, as example 1 is a piecewise split function. So the solution to this is to let m represent the length of a call in minutes. This is where we get to talk about this algebraically, right? Example 1, we kind of figured this out how most non-mathematicians figure things out, right? This is how you would figure it out in most situations in everyday life. But what if you're running the business? What if this is your business we're talking about? Or what if this is really important financial matters that you need to take care of? You're going to need a little bit more, let's say, sophisticated mathematical technique to keep track of what's going on and how much you're charged, okay? Let m represent the length of the phone call in minutes. Let the c of x, that's how we interpret this little expression here. The c of x, what this is called, the c is probably what they're thinking of is that this is the name. This is the name of the function. X is going to be the variable. So probably the name, they called it c of x because they're thinking this is going to be the cost. I'm guessing that c stands for cost here, cost of the phone call. So this is the cost function, the c of x, to represent the cost of this call. So first, we're going to represent the cost of this call. That's 3 minutes or less, which is 35 cents. So we're going to say, the cost, the C of M, is going to be 35 cents whenever M is less than or equal to 3. Because remember, they're going to charge you that 35 cents for that first 3 minutes. If you talk for 30 seconds, they're still going to charge you that 35 cents. That first 3 minutes is 35 cents. They're not going to let you charge with like a portion of this, right? That's how these companies kind of do these things. And if you talk for 1 minute, they're still going to charge you the 35 cents for all 3 of the first minutes. If you talk for 2 minutes, they're still going to charge you for the 35 cents for all 3 of the first minutes. So if m is anything, we probably should have said when m is greater than 0, right? M is greater than 0 too, because we don't get money back when we don't make phone calls. So when m is greater than 0, or when m is less than 3, the function of this is going to be 35 cents, right? If you talk for 2 seconds, or if you talk for 2 minutes and 59 seconds, they're going to charge you 35 cents. So this is what this is saying. This is saying that if you talk for less than 3 minutes, you're going to get charged for 35 cents for this phone call, no matter how little you talked. As long as you talk more than a second, when m is greater than 0, 1 second or more, up to 3. Okay, so that's the first part. Next, we're going to represent the cost of a call longer than 3 minutes. All right, the cost of a call longer than 3 minutes, where m is an integer. Now, an integer is a whole number, positive or negative. So remember that integer is a whole number, positive or negative. The first 3 minutes cost 35 cents, but we have to add on a charge of 19 cents for each minute over the first 3. So we're going to use the expression m minus 3 to represent the number of minutes over 3. So here we have the same thing we had over before, right? This part here is the same as what we already did. That hasn't changed, okay? What we've added to this little squiggly says this whole thing is part of the cost, the C of M. The whole thing is part of the C of M function, the cost of minutes function. All right, so now we're getting charged. This is for when m is greater than 3. You talk, say, if you talk for 10 minutes, right? The first 3 minutes are going to be 35 cents, and every minute thereafter is going to be charged 19 cents. So how did they express this? They expressed it as m minus 3. Do you kind of see why that makes sense? M minus 3 is kind of what we were doing above when we subtracted 3 in the beginning. Remember on this example here when we subtracted 3 right from the beginning? M minus 3 is doing the exact same idea. It's saying don't count the first 3 minutes. That's what that's saying. It's saying don't count the first 3 minutes. Every minute that's greater than 3. If it's, say, 10 minutes. If you talk for 10 minutes on the phone, 10 minus 3 is 7. So the first 3 minutes get charged 35 cents. And then 7 times 19 cents is going to be the cost when you add those two things together for the total call. Oops, sorry. I get carried away. I need to figure out how to turn this a little bit easier. Okay. So if m is greater than 3, but not an integer, use the greatest integer function. If you use a portion of a minute, you must pay for the entire minute. So if m is greater than 3 and m is not an integer, you must pay for m minus 3 plus 1 minutes. All right, let me see if I can show you how to do this on your calculator. Dare I risk this? Dare I risk this? I don't know if I dare risk this. Let me try. No, I kind of want that to go away. I want this to pop up. Hopefully my computer can handle all this. There it goes. There, I'm already stretching this computer to its max just with this video streaming thing. All right. There's our calculator. There's our wonderful calculator that we all know and love. Let's see if we can get this thing to do this. Let me show it to you. No, I won't let me. There I go. There I go. There it is. All right. No, now it went back to the other side. I don't want it. I don't want you on this side if I can help it. Can I just want you? Can I have you over there? Okay, great. Wonderful. Thanks, calculator. All right. So as you saw, I went to y equals here. All right, I went to y equals, and I want to put some of this function in. So my first step is going to be, I'm going to put this in as 0.35, and then I'm going to, so that's kind of like what I've got over here, and I'm going to put a limit on this function. I'm going to put a limit on this function. And how I'm going to do that is I'm going to press the divide button. I'm going to press the divide, because remember that thing where you can't divide by 0? You can't divide by 0. So we're going to try to play around with that by doing a division and put a limit on this thing. So we're going to put in x is less than or equal to 3. Okay, and how you do that is you have to use the test function on your calculator. Go to second, test, and then I can see that the greater than is right there. So, I wanted less than or equal to. So I want to go down to 6, less than or equal to, there it is. X is less than or equal to 3. And I close this, and watch what the awesomeness that happens when I graph this. Did it work? I can't even tell if it worked. Ah, wonderful. Do you see what it just did? It just stopped right there. Why do you think it stopped right there? Well, let me try to zoom standard. Let me try to zoom standard here. And maybe that'll give you a better, I think it's going to stop. All right, did I put the wrong thing in there? Well, 0.35. All right. Oh, all right. I got it. The reason why it stopped right there, right, is because it's saying graph this function when m is less than or equal to 3. So it stopped right at 3 because we have graphed this function with a limit of 3, right? Keep graphing this thing until x is no longer less than or equal to 3. All right. Now that we got that, I'm going to show you how this is how we kind of graph these piecewise functions on the calculator. All right, this is a lot. Let's see. So I'm going to do another function. The next piece of this function I'm going to graph over here. 0.35 plus 0.19. That's 19 cents for every minute less than 3, right? So for every minute, for every x minus 3, and then again, I'm going to press the divide by, use my parentheses, and say that when x is greater than 3. So when x is, second test, greater than, I got to go down to there, greater than 3. All right, let me graph that and see what that does. Okay. Oh, look at that. The next piece just started graphing. So it's 35 cents, 35 cents, 35 cents, 35 cents, and then right here, it starts to go up. Now, this is not ideal. And I'll tell you why it's not ideal. Because this is a piecewise function. Remember that part where we only get charged? Oops. I got to press that a lot. That's not ideal. This should have little piecewise functions going on, but instead, it's a continuous line. I don't like that. I would like to change that using the integer thing. So let me see if I can try doing that. This is some pretty advanced stuff. I don't even know if I can do this. So if I fail utterly, don't laugh at me too hard, okay, people? Don't laugh at me too hard. All right, so I have to use some advanced stuff here. I have to go into the, I pressed math just now, and I want to use the integer function. I'm going to see if I can use this. I should have tried this before I got on this video. You know what? I feel like sometimes it's good for you guys to see that that we are human, us teachers. That we have to figure things out too. We have to figure things out too. You're not alone in that. If things seem hard, it's because we make it look easy because we practice. That's really what it's about. We make it look easy because we practice. Oh, I did something wrong there, right? That's not what I'm hoping for, right? That red line there, that's not what I was hoping for. Here's what I was hoping for. I was hoping for that blue line to go like there, and then all of a sudden to bounce up here and do a little step, right? Like a little piecewise function. Let me go back and see if I can improve this at all. Okay. So what I was trying to say to the calculator was say that make this an integer. So let me, I might have to clear this out. As disappointing as it is, I'm like you. I don't like to redo my work, but you know, hey, sometimes you gotta. So plus 0.19 times x minus 3. Now, do I want the integer of x minus 3 here? All right, I'm gonna try the integer here. I'm gonna try math, number, integer. All right, x minus 3. All right, and then I'm gonna add plus 1, right? Plus 1. Plus 1. Close. All right, I'm closing the parentheses that I started over here. And then I'm going to try to do the division thing again. I'm going to divide, close parentheses, open parentheses, x is greater than 3. So I go to second test. Let's see, I'm going to be pretty impressed with myself if this works. X is greater than 3. Okay, all right. Let's see if Mr. Schultz got it here. And it should pop up. If I did it right, it should pop up here. All right, maybe. It did it! It did it! Let me. Oh my gosh! This is so neat! You guys are probably a lot less impressed than I am. This is kind of neat, right? I made the calculator do the little pop-up thing, I think. Oh wait, it kind of did the pop-up thing, but then it kind of didn't too. Oh, I'm going to use my mouse for this. Oh, I was so close, right? I was so close. I'm going to zoom in to kind of show you what's happening. I don't think, what I should be seeing is a little flat thing. And I don't think that's what I'm seeing. I'm not seeing flat. It's jumping. Oh, it is flat. No, it's good. This is working. This is working. So it looked like it was doing a straight line. Oop, no, calculator, come back. All right, it looked like it was a straight line, right? The way it was graphing it. You see what it's doing? It's like hopping up. What it's saying is that for every additional minute, there's an extra 19 cents. Now, see, the thing is that it doesn't look like it's hopping up much. But remember, 19 cents isn't that very big of a piece of one. Of course, the jump is little. But this is a piecewise function. Now, keep in mind, the calculator will not graph for you your closed and open circles, right? So, and all that. But this is a graphed piecewise function. And this is some pretty advanced calculator stuff. I mean, maybe there's some math teachers out there that do this all the time, but I'd never done that before. And I think that's pretty nifty. Now we have a new tool, because remember, that looks like a straight line. Remember, that's little piecewise little steps in there. Okay, well, so we did this. Okay, we graphed all this. This is the completed piecewise function. And so let's think about what this is saying. Ooh, no, I didn't want that. I don't know what that's about. Thanks, but go away. Okay. If you substitute 7.5, remember that was our problem here. We wanted to substitute 7.5 again. Remember, we did that already up here. We already figured out what 7.5 was. We figured out the cost should be $1.30 if we did everything correctly. And then this is kind of showing you how to do it in terms of that very more sophisticated math of piecewise functions. So here's my 35 cents. Here's my 19 cents for every additional minute. I have to do 7.5 minus 3. That's my m minus 3 I had up here. 7.5 minus 3 is what? 4.5? 4.5, right? And it's going to be plus 1 because it's going to be rounding up. Rounding up. And so 35 cents, if you put this in your calculator, let's just prove it. Sometimes seeing is believing. I know this makes it slower. If you want to skip a minute, go ahead, be my guest, 0.35. You can skip ahead if you don't want to. If you trust that I already did it right on the first time, 4 plus 1, $1.30. $1.30, just like we got before. This is that sophisticated piecewise stuff, figuring these out. So here we go. Here's your chance to shine. Here's where you're going to do this because you can do this. You got this. You're all very intelligent people. Give this a shot. Give this a shot. Pause the video here. Try. Honestly, you learn a lot from making mistakes. So if you get it wrong, that's not bad. That's good. I mean, I'm not going to say it's good that you tried, whether you got it wrong or right. Okay? Yeah, it'd be great if you tried and you got it right. But don't let that stop you. Don't let that stop you. You don't get good at something by doing it like an expert the first time every time, right? You get good by practice and getting them wrong. If this is basketball, if this is piano, if this is a foreign language, you learn by doing and trying and practicing and sometimes, oftentimes, a lot of times, failing until you get it right, until you get it perfect, until you're awesome at this. And it only happens with practice. You got to practice to get good. So I want you to pause and give this a shot. All right, great. You are now unpause me, and I'm going to show you how to do this, right? All right, a payphone at a baseball stadium charges 65 cents for the first 5 minutes. Wow, they're trying to get you for they're trying to charge you big for the first 5 minutes. In other words, if you have a phone call for less than 5 minutes, you still get charged at 65 cents. You're still out that money. They're going to charge you 22 cents for each extra minute or part thereof. Remember, if you charge for 5.5 minutes, they're going to charge you for 6 whole minutes. Express the cost C of m in an m-minute phone call as a piecewise function using the greatest integer function. So, all right, let me give this a shot. All right, and I need practice at this. Okay, so let's see. Normally, I would start with like y equals, and immediately what I wanted to do, but they already gave me this here. So I really should start this with C m, the cost function in terms of minutes, the cost C of m, the cost in terms of minutes, right? The C of m equals. Now I'm going to need this thing here, right? Because I'm going to have a couple different expressions. My first expression is really easy. It's going to be what? What did I just do? Do you know what I just did? I'm saying that 65 cents for when the m is what? When the m is less than or equal to 5. Why 5? Because for the first 5 minutes, right? What I'm saying here is that the function, the cost of m, the C of m, is going to cost 65 cents whenever the minutes are 5 minutes or less. 5 minutes or less also when m is going to be greater than 0 here, right? Because we're not going to get any charges if we make no phone call. You can't make a negative phone call, right? Negative minute phone call. All right, so now it gets a little harder. A little harder after this because we're going to still have our 65 cents. And hopefully you knew that. And now we're going to add something to it. What we got to add to it? I'm pausing here because I want you to prompt you to think. Okay, I got my rate. My rate is what I got to add to it. I got to add 0.22 minutes for each minute. 22 cents for each minute. How am I going to express that? I'm going to put times, right? I'm going to multiply 22 cents times the minutes. What if I leave it here? Do I leave it here? No, right? Remember that other problem? I had to subtract, right? I had to subtract a number. Last time I subtracted 3. This time I'm subtracting 5. Why am I subtracting 5? Because I don't want to be charged. I don't want this function formula to charge me 22 cents for my first 5 minutes. So I'm taking away essentially the first 5 minutes, and I'm accounting for those first 5 minutes over here. Over here is where these first 5 minutes, the cost of those first 5 minutes is getting added to the function. I'm subtracting by 5 minutes over here to account for this 22-cents thing, when m is greater than 5, right? When m is greater than 5. And I am going to make this go away to make sure I am doing this based on what we did before. I'm just going to remind myself, okay, there's my 35 cents when m is less than 3. I got this when m is an integer. Oh, when m is not an integer. So I need the expression for when m is not an integer. Okay, so here I go again. Where am I? Well, there we are. And some of my stuff got deleted. I don't like that. Okay, but you can pretty much see it. There's my 65 cents. There's my plus. There's my plus. I need 22 cents. And I should probably write, when m is an integer here, but I don't know if I can. When m is integer. I'm not going to require you to write all of this in here, but when you do this, well, here's what I should see. I should totally see this and this, right? No, that, right? I need to see these two expressions here. And usually how I write this, if I'm doing it short answer, I say like, the C of m is equal to, and I'll do 0.65, comma, when m is less than or equal to 5, and then I do a semicolon to break it up, and then I do the next piece, 0.65, and I get going. So each one of these gets a semicolon break, and then this part here gets a comma break, okay? If you think of that as a comma there, a semicolon at the end of each one of these, you get an idea of how you might do this in one line. I know that's a little bit harder. Sorry, that's the Google Forms. That's just how it works. All right, and then back where was I? Oh, yes. I was doing my greatest common integer stuff. So I still need to do m minus 5. But what am I doing? I'm going to use the greatest common integer plus 1, right? Remember that plus 1 is going to bump me up. It's going to bump me up to this is going to send me, this little bracket here is going to send me to the greatest common integer, and then this is going to add 1 to that integer. So say, for instance, if m is 10.5. 10.5 minus 5 is 5.5. Greatest common integer says 5.5 becomes, oh, I need the bracket here, don't I? If anyone caught that, you are awesome. You are awesome if you caught that. So you see how even as I was thinking about the math, talking about it out loud, I realized that where I needed this greatest common integer. Why didn't I want it over here? Because if I have the bracket over here for greatest common integer, then I'm adding 5.5 to 1, and I get 6.5. Oh, actually, that would work. I take it back. Either one works, and I actually like it better the way I had it before. So you're not wrong to do it this way, but I kind of like it better the way I did it before. Let me rethink of this. If m is 10, if I talk for 10 minutes, I'm sorry, 10 and a half. We need a non-integer number to mess with to make this for this piece. If x is 10, if m is 10 and a half, 10 and a half minus 5 is 5.5. All right, I'm going to take 5.5 now, and then I'm going to add 1. What did I get? I got 6.5. 6.5. And then what do these brackets say? These brackets say greatest common integer, so 6.5 becomes just 6. I just dropped the 0.5. I'm not rounding here. I'm just dropping all the decimal places to go to the greatest integer, right? And then that is when m is greater than 5, and when I'm doing this proper, when m is not an integer. Not an integer. All right. That's the whole thing. Yes, this is quite a bit, right? This isn't super easy. Whenever I'm asking you to express, whenever you see this express, I'm probably mean express algebraically, and you can know that expressing algebraically is that higher order math. And the reason why I make you do that express algebraically stuff is because if you can express it algebraically, gosh, you can do it if you've got the numbers, right? If you've got the numbers, you can usually muddle through and get something. You can usually muddle through without, if you only have the numbers. You can do stuff like this, but you'll have trouble explaining how you did it, right? There's going to be a lot of steps. There's going to be a lot of math. Things are going to be unclear, right? What the advantage here, the reason why this is more sophisticated, sorry about that. That's going to ring actually. Nope, it's going to be the 45. Okay, so it's going to ring a little bit. The reason why this is more mathematically sophisticated and why mathematicians use it is because in this little tiny piece, you can describe all the little steps it takes to calculate the cost for every minute. If you didn't do this, oh, I got to tell my Google to stop. Hey, Google, stop. That's a little warning bell that says, hey, it's time to remember that the kids need to go to bed. So I need to get off this video real soon and get my kids to bed. All right, so we took care of this one here. We took care of this one. You know what? I think I'm going to stop the video here because I kind of wanted to break these up into several pieces anyway. So this is a good time to, a good place to take a pause and take a look. Oh my gosh, and there is the craziness, right? So I need to get rid of my screen capture again. Hi, Freya. I'm going to cancel that. I want to back to me. Hi, I'm back. And there's my daughter, Freya. Okay, bedtime for you. Do your nighttime routine, okay? But.
I want to like buy something on Roblox, but
He wants to buy something on Roblox, folks.
Also, I promise if you buy this thing, I'm never gonna ask for another thing again. All right? Never.
I'm sorry, dear, but there are no in-app purchases in this household. Okay? Nighttime routine. Go.
So I forget.
No. Oh, I'm recording. Okay, sorry about that. But this is, I'm trying to do my best here. Trying to do my best. We all have real lives and things got going on, right? All right. So thanks for joining me. I did examples 1 and 2, and then we'll do more examples in next videos. Okay. See you next time.